Hi, this is Bits and Pieces, the official podcast of Component Supply. I'm Kristen.
And I'm Mark.
And today we're going to be talking about your end game. Do you have an end game?
Yeah, it's planned. Everything is completely planned out from start to finish.
Okay, so I think that when you're talking about that, you're way up here. We're going to narrow the focus to...
I'm going with business plan here.
Oh, no, we're going to just be talking about hypotubes
or like project.
and wires.
Oh, that's it?
Yeah.
Oh.
Sorry. So in case you were about to think you're going to get the component supply in-game revealed, we're really just talking about the end forming and tip grinding for tube and wire today.
The end game of the tube and the wire.
Yeah. So what's your end game? So that's what we're talking about today.
My end game should be to prepare a little bit more for this so that I know what's going on.
People are getting the real Mark and Kristen at Component Supply situation where we do a little bit fly by the seat of our pants. And occasionally a Wednesday morning at 9 a.m. hits us really hard because we're like, oh, it's podcast day, and we have to have something to talk about. We do have a list of things that we do want to talk about, and one of them is dealing with end treatments, value-add services for tubing and wire. These are things that are increasingly asked of us from a prototype perspective. Some of you just wanting a piece or two to test with. You want it turned around quickly so you can see if the tip geometry works for your application. Some of you already know exactly what you need. So I want to dive into a little bit of the different kinds of tip grinds and end treatments options that there are and why they might benefit your application, what some of our customers are using them for at kind of a high level, and just something for you to consider when you are in the process of using hypotubes and wires. We're going to assume for the point of this episode that they're already cut to some sort of length, plus or minus, some sort of tolerance. We're not going to go, some of you want them super short, and some of you are dealing with a really long guide wire mandrel application that needs some sort of tip. So it just depends on what you're using it. So we're not going to go into like length options and any impact that would have. We're going to just focus on the end game.
I gotcha.
It just has to be done.
Okay.
So there's geometry, right, that matters. And one of the things that we recommend to all of our R&D engineers, because a lot of times you're using like a hypotube with some kind of tip on it, and you're going to put that in a greater part of an assembly, right? Before you put it into an assembly, we do want you to test geometry. So that's why you can come to Component Supply, get an end form or a tip grind, and be able to test a couple of pieces before you put it into an assembly and start testing it. Because sometimes the rest of the assembly is great. Mm-hmm. It's just you've messed up some angle on the tip. So geometry matters. If you're like mating components together, it matters. If you're navigating tortuous anatomy, and so you have to have a special tip on it for, just protection and safety. You're dealing with pushability, insertability. So you have things like that. And certain geometry changes can affect things like on a mandrel, there's a difference between a full radius, bull-nosed end and like a chamfer versus an aggressive deburr. In those situations, oftentimes because you're putting something over the mandrel, you don't want it to snag or tear. Mm-hmm. So you have those kinds of issues. They seem kind of minor in the grand scope of your device, right? But we're Component Supply. We're worried about your components, and we want you to test those things pretty early on. So I want to talk about the capabilities, and I need your help reminding me of all the end options.
All the end options.
Yes.
All of them.
Don't ignore the ones that aren't your favorite. You gotta be bold and brave here. We say we're gonna do it, we're gonna do it. So we want to break it into two sections. We're gonna break it into the wire applications, and we're gonna break it into the hypotube application. So at a high level, maybe let's talk about the wire ones first, informs. Okay. What are some of the ones that our shop is seeing frequently lately? And maybe then we can go into like why they're using those. Okay.
I think anytime you do this, you have to just start at the most basic. Mm-hmm. So just a straight cut. Mm-hmm. And then from that point, you kind of just move beyond that. And so that's one that people shouldn't ignore.
Just having a burr-free straight cut.
Yes, because that has lots of implications in terms of like, okay, well, what is burr-free? The minute you do that, a process starts to then erode kind of the edge of that cut.
Yeah, fair enough.
And some applications require a very sharp, a very sharp cut. They don't really want, any sort of of material removing around the edge of that cut. So that's the first one, and then you just start moving back from there, right? So like at this point now we have something that's kind of deburred, so it just starts a slight radius or movement around that edge.
Yeah.
And that can be done in a couple of ways. We either have like a radius edge or a chamfered edge, and so.
And there's a spectrum.
There's a spectrum there,
right.
And so you can get there are call outs there. Radius is easier to achieve than, and I don't want to say easier. It's more cost effective.
It's faster.
Yes. Versus,
especially if someone's calling out an angle on the chamfer, right?
That's it. They call it an angle. They call it some distance that they want that angle to be. Move back, and really, what you did is you introduced measurement, and so an inspection, either both in process and final,
right?
And so anytime you do that in an application, your cost and it gets more difficult. There's more hands in it, and the cost goes up. Then you move all the way to a point grind, right? So now we've got like a pencil point. Same thing. It's challenging to accomplish. They've usually called out, a number of things in order to get that. Sometimes they call out too many things. They've called out an angle and a distance, and generally their math lines up. But they've also tightened it in so hard that now there's some inspection criteria that becomes more challenging. Those are things to consider. Then you've got like a simple bevel grind. So we're just simply putting one angle across the face of that.
Yeah.
And then you can move to some sort of a lancet grind or a trocar, and some other more complex geometries for wires.
Tell me, or let's talk about how a coated mandrel or coated wire, what implications that has on your endforms. What should engineers be considering? Again, we get a lot of requests for this. You want the mandrel coated, you need a long wire that's coated, and then you want us to perform some sort of end on it. What considerations should they be making when they're considering coatings?
Probably the greatest thing is naturally they focus on what's going to happen around the tip. That's actually not the problem. It is a problem, but ultimately when you're going to grind something on a coated wire, if you're not going to coat it after the fact, which a lot of times it's an option, but a lot of times that's not really necessary,
right.
or actually they don't want the tip coated, but they want everything coated right up to the tip. There's a lot of challenges there. But the real issue is, in order to actually perform this function, you have to hold. There's work holding that takes place. Well, what happens in the work holding is you're going to damage the coating, and to control the wire in order to get an accurate tip grind, it's going through certain guides. That's also going to mess up your coating.
Yeah.
So there's a lot of risk in grinding the tip of a coated wire.
Right.
Not so much at the tip,
right.
but the rest of the wire.
Well, it's like when you send material out for coating, right? You're always going to send some extra material. There's always going to be some scrap in the setup process. Always, we always take into account that even just when we're sending for coating for our own applications, there's not perfection. We don't expect perfection. And so when we're making components, we're gonna make a few extras. You're gonna order 100. We're gonna make extra because we know we give space for human error, because we know that in the material handling process there is going to be some scrap, there is going to be some damage. So you might want to take that into account as well, and just note that your pricing is going to encapsulate those extra parts.
Well, one of the other
materials.
things to consider too is if you're developing something and say you want it ground in like an ECG process, but it's coated, it's an insulated product. You're not gonna be able to do that without creating some way to conduct electricity. So there's considerations around coated wire that make it more challenging. Yeah, from a standpoint of damaging the whole product.
All right. So in the case of a chamfer versus the full radius bullnose, I would say we probably see more full radius than we see others. But again, there's a spectrum. I'm going to throw up an image of this that shows you kind of a range of the different options. Because if you can open up those tolerances, even on your bullnose, then that can affect the cost effectiveness, right? We have a bigger tolerance, right? The wider your tolerance, the better as far as a price goes. But we understand also that not every application has the option of a wide tolerance. So you can kind of, when you're talking with anybody, any of our reps, they'll ask you, okay, are you looking for 1, 2, and 3, or 4 and 5? They give you some different options, and so we'll kind of show you what some of those ranges can be, so you can make those decisions.
I think the important thing there when you're designing this is don't focus on the tip geometry. That's not the point.
Yeah.
Unless it's a point, then you need a point, right?
You did it.
I did it.
Good job.
I can play this game.
Okay.
So many times, particularly in that case, when you're talking about you're trying to accomplish something. What is the purpose? Not the geometry. If you're trying to put something over it, you want it to find centers. Once you define what you're trying to do, you can sometimes the geometry matters less than you think in terms of accomplishing what you were really trying to accomplish. You weren't really trying to accomplish a geometry.
Yeah.
You were trying to accomplish a task.
Yeah.
And I think that's important for product designers to understand, to a point where we would much rather somebody call and say, we're trying to do this thing, and we don't know which one would work. Our shop would much rather make you a handful of parts of different, in some range,
yes,
and let you test it and say, oh, like all of them work, than to be tied into doing something that's difficult, that may be unnecessary and add cost and time to a project. Yeah,
we're really willing to work with the small quantities of various tip grinds and informs so that you're able to test before committing to the large volume. I mean, that's what component supply is all about. We want you to test early on. We talked about the this or that questions a couple episodes ago. We want you to ask those questions. Should it be, can I get away with just an aggressive deburr? We don't need to just break the edges a little bit versus a full radius versus a chamfer. Like, what's going to work in your application? You want to try all of them? We'll work with you to make that happen early on, so that you're not committing to something too early on that you actually don't really need, and that's going to be cost prohibitive later.
I know sales will probably hate me for saying this, but when we're, especially in the research and development, it's kind of the prototyping stage, if they say, hey, make us, 10 of these things, it is not that difficult for our team to say, okay, but why don't I make 5 of them? I'll make 10 of these, and then why don't I make 5 of them that are like this? Which so let's make it. Let's say it's some radius. Let's make 5 of them that have a little more radius, and 5 of them that are a little less radius, so that they can at least test it. Yeah. We're in the middle of it. It's just not going to take us that much longer to do that and give customers the options to say, the one I ordered was the best, or actually all 3 of them it doesn't even matter. Nobody can tell a difference.
There's no difference.
But it's not a lot of work for us to just do that real quick.
You're that good.
We're not. We're just there. We're already in the middle of it.
Well,
what's the big deal?
It's funny that you say that, because Courtney and I and whoever's quoting jobs, we'll try to be like, how long did that take them to do this little prototype? And I'm like trying to bullnose it in my head, and sometimes you're like, Kristen, it takes a little bit longer than that.
Well, it does, but once you're set up and you're going to do 10, to do 10 more real quick, and give the customer some option. The biggest thing is to get the customer to realize, okay, well, so basically you're going to send me the 5 things I want, then you're going to send me, or whatever, the 10 things I want, then you're going to send me 5 of 2 different things that I didn't want, but to at least test it and have customers say, what, I get that I'm okay with that. That's kind of, I think, the biggest challenge. Our shop is willing to do that.
It makes me want to have a little competition in our shop to race to see who can give us 3 variations in the shortest amount of time. Sounds like a Wednesday.
What happens in so many cases, because our shop is not, we don't have robots. We have to watch them because they go rogue.
Yeah,
They
I know,
literally
you
they
mentioned
make
that
the
for
parts
sure.
and then they're like, "Hey, we made these extra parts." I'm like, "Yeah, but we can't send them because they're going to freak
They
out."
go in this box of wonder that
Right.
changes constantly because, it's like show and tell in the shop. And I'm like, I don't really know what to do with that. But I'll put it in the box in case it comes up on a podcast episode or something like that. All right, let me make sure I stick a little bit to our notes.
Okay.
Just one kind of rule of thumb, if your mandrel is coming in contact with a polymer, probably the closer you get to a full radius and the better, versus like a chamfer might work for more of like an insertion kind of application. So just ask us. And again, a lot of you are pretty vague, and I understand you want to be discreet. You don't want to give out all your, secret sauce. But the more you can tell us about your application, we'll sign NDAs, we'll do whatever you need to do. But the more you can tell us about your application, the better we're equipped to help you. We do see these things sometimes. We do know what is beneficial and on a very general level what is preferred. So if you can ever just give us a little insight into what you're doing with the parts, that's helpful for us to give you advice if you're struggling. All right. Let's move into hypotubes. And again, most of the same kinds of tip geometry there, tip grinds. There are a few extra bonus features.
Yeah, there's some
for hypotubes though.
The thing that hypo, again, okay, we're gonna put a very, very square cut. We're gonna now deburr it, which is gonna put some radius. We either cut it through ECG or there's a manual deburring process for the ID. That's a problem. There's bevel cuts, there's lancets, back grinds. There's Francine. There's all kinds of different grinds you can do.
And they're so cool. I mean, those are the ones that are at the trade show on our little stands where people point at them and they're like, if they're not in this segment of med tech, they're like, are those tiny torture devices? We're like, no, man.
Yeah. And then we've got, our group, Mike, who'll set up and do a job, and he's got the material, he's got, he's finished it, and now all of a sudden he's like just making up stuff to
again,
like what
the
stuff in the box. But one of the things about hypodermic tubing or tubing in general that we see, and it's sort of like, I get it, and at the same time, I just want to be like, you're going to have to find something else to do in your life. Is the ID chamfer? They want a radius on the outside diameter, a radius on the inside diameter, and then they call it out of all things. Not that that's impossible. We can accomplish them. But do we need to? That's, I think, my question.
Just because you can doesn't mean you should.
That's one where I would caution people to call out some spec on the ID, unless the application is absolutely critical, and then
a spec on the ID,
on the inside diameter, a radius on the inside the inside diameter.
Okay.
I get it on the outside. It's very easy to accomplish and measure. The inside diameter, not impossible, but at the same time, it gets a little tricky. And so
I'm sorry, you want them to call out?
No, don't call
Don't
that
call
out.
out. Okay.
Did I may have missed that right? No, don't. I mean, if the application, and if they feel like their application does, I think this is where we have a conversation. This is about what do you want to accomplish, not what do you want the geometry to look like.
Yeah, it's a great conversation to have. If you're early enough that you're not like into revision process, you're not locking in design, if we can answer that question. Yeah, what are you doing versus the geometry itself or the specified
Because
angle?
there are ways to handle that may be more cost efficient, and I think that's worth the conversation.
It is one of those things though that it's really not that hard to pull off in a drawing, but in real life it's difficult, and you can make it. The design and reality do not always have perfect unity, and so that's one of those examples. I do want to mention, if you're buying off the shelf, bulk, volume, the same day shipping stuff, can we talk about pinch gens, because that does occasionally surprise people for if you're buying off the shelf hypotubes.
Yeah, I think you've got so depending on what you're doing. And you're pointing the buyer. So obviously we have customers who are going to buy one piece off of our website, but then we have customers that are buying parts that they use into production. And for us to go through, if somebody's going to buy, if they're ordering 15,000, 20,000 feet every month or every 2 months or something, to incur the cost for us to either straighten or run through material, finish the ends, deburr it, to add that cost, that value into it doesn't make sense. They're going to put it into their equipment and cut it up anyways. And so many times they're going to do a crop cut in their thing. So they're going to cut, if it's tubing, they're going to cut a pinched end off. Or in wire, we're going to have like a shear cut, which is going to be, it's going to have a little deformation or something like that. And so, but in so many cases, particularly in production, that is, and at volume, we're not talking about, whatever, 1,000 feet or 600 feet. We're talking about, enough production volume that those value services really do skew the cost. There's no sense incorporating those costs. And so, yes, whether it's a shear cut or a pinched end for tubing, that's the way those raw materials that I kind of look at them, that's the way they're processed. And so if you're using it in manufacturing, accepting those kinds of ends can lower your initial cost. Now, they may have value in saying, hey, look, I don't want a pinched end. I don't want to have to deal with that. And that's fine. Those are conversations they should have with us or other suppliers. But the option is out there.
Right.
They may find they can handle that efficiently and save raw material cost.
Yeah. So from our perspective at Component Supply, when we're dealing with hypodermic tubing and any kind of end form tip grind situation, a lot of times it is being used in an assembly. It's being used in like a fluid management system in some way, or a drug delivery where like precise suspension is really important. So, an angle. I do want to warn against just saying like a standard bevel. We don't call out a standard anything because we have had so many of you request standard, but what you mean by standard is different back bevel, different bevels standard means different things to different people. So always call out your spec.
And the ASTM doesn't call it out clearly either. It is, they call out, it's really up to you. You have to define those angles. We can help you, but the reality is, or we can at least tell you what we have seen in the past for in various applications. But that really needs to be called out. Both, even in a lancet where you've got your primary and secondary angles, you really need to call that out. There isn't just some magical standard out there that. I feel like they would standardize the hub colors first before they did that, and they haven't done that. So I think we're a ways off from standardizing.
Yes,
angles.
for sure. Well, at any rate, whether you are using it for dispensing, that's going to require a certain angle versus and that depends on your application, versus your trying to penetrate some sort of a septum, that's a different application, requires a different angle. So so don't just use standard and assume that we'll understand. Please call out your specs. That's just preferable over time. We'll work with you to determine what that spec should be. Again, we can provide various options if you want to test certain things in small quantities before, welding it into a hub, before gluing it into an assembly. We'll help you with those things. So that's, again, high level. What's your end game for hypodermic tubing and wire? Anything else you want to add?
No, we enjoy end forming, so we like people's end games.
Yes. So what's your end game? Let's go change the world.